All right, so welcome back. We going to learn what the unit circle looks like. So the most important thing is in the unit circle, we definitely have to know which one will be the side directions, which one will be the cosine direction. So let me just point it out real quick. This part on the x-axis. So this is what we call the x-axis. So that will be the cosine. Okay. So in this, when it go to that direction, so the cosine is positive. When we do on that direction, then this one is negative. Okay. I'm sorry, it's positive as well. I'm sorry. This is what we call for the side functions. And so this will be the y, and this will be the x. So the x represent the cosine, and then the y represent the sine. So in the unit circle, the r will be equal to 1. Okay, so there's no doubt about it. Um, anyhow, so what the psi function is with respect to the angle. So the angle is when we take the sine. So if we want to do the sine of the theta, in this case, so that would be equal to opposite. So the opposite is y, right? Over the unit circles are equal to 1. So this is what we have for the y. Okay, this is what I mean. So similarly for the cosines of theta is when we take the adjacent over hypotenuse. In this case, the adjacent is x, hypotenuse is r, so r equal to 1, and the answers for that will be equal to x as well. A very good important identity for the trigonometry is so using the right triangle property, the Pythagorean theorem. So this is what we call the right triangle. So apparently that we can literally see we have the x squared plus y squared equal to r squared. Okay, so when we check that, we have x squared plus y squared equal to r squared. Well, we know the fact that r equal to 1 for the unit circle, so meaning that the x squared plus y squared equal to 1. In fact, the x that we have for the cosine, the y, the sine, and then the y represent the sine as well. So it can also rewrite this the cosine of theta, where theta will be the angle in the first quadrant of this circle, and plus the sine square. Equal to 1. So this is a very important characteristic that we need to know, and this is applied for any angle for any radius. For that, the answer is absolutely yes. So we can also apply with this with the r not equal to 1, and then when we take the sine square, we're going to get y squared over r squared plus cosine squared, which is x squared plus r squared, and then we're going to get y squared plus x squared on numerator and the r squared on denominator. And so x squared plus y squared equal to r squared, and add up equal to 1 as well. So no matter what happened, this always going to give us r equal to 1. So there's no doubt about it. So let me just highlight that part, and I'm going to use that as a fact when we try to do with the unit circle. Okay. So as a previous lecture, so the data in this case will be between, for the first quadrant of the circle, that is between 0 and pi over 2. Okay, so this is a very important thing. So what is the pi over 2? The pi over 2, basically 90 degrees. So as we have learned earlier, that we can basically know how to convert the radians to the degree and vice versa. So it doesn't really matter how we're going to write them down, either in terms of the degree or in terms of the radian. Okay, so it's just how we look at it. The pi is 3.14156, 159. I apologize, and but the degree is the whole circle is 360 degree. So when we deal with the first quadrant of a circle, so the answer for that would be from 0 to 90 degree. And for that reason, so we're gonna basically know how to take the sine and cosine in a certain thing. So what happening is that what is the size of theta equal to 90 degree. So when the size of theta go to 90 degree, that we can literally check that the point that we have will be right there. Okay, so this is where the theta equal to 90 degree, or pi over 2. So just want to make that simple. We're going to use the pi over 2 for that reason. But there's nothing wrong with using a 90 degree or pi over 2. They both yield the same answer for that. Okay, so this is where an angle goes all the way to the right angle. That's this point x and y basically go all the way to this is 1, and this is also 1. Okay, and apparently, so the r in this case will also equal to 1, as we have learned that part, right? We're gonna deal with the unit circle for that. So now we're going to consider when the size of pi over 2, when look at that, the angles go all the way to the y. So when so this is the point that we can see that y equal to 1, and what is the value for x, so we can literally check that the x equal to 0. So a psi pi over 2, meaning that this is basically the same as size of 90 degree. And that literally equal to 1. Okay, but however, the cosine is literally 0, because when this point x and y go to that part, so all the value that when you look at the x-axis will be equal to 0. So meaning that the cosine of 90 degree vice versa would be equal to basically another way that we can write, that would be the cosine of pi over 2 and equal to 0. So what is the better way that we can look at it as well? So do the math with this, because psi equal to 1, right? And so so square also 1, so we subtract 1 both sides, going to get cosine theta square equal to 0, meaning that cosine of pi over 2 is also equal to 0. So another way that we can look at is the cosine square of pi over 2 plus size square of pi over 2 and equal to 1. So this guy equal to 1, right? Meaning that this guy have to be equal to 0. As simple as that. Okay, and now when we look at this point, this is where the theta equal to 0. Okay, so what's happening for that part is what is psi of 0? And so what is the psi of 0? So we can literally see that the psi of 0 is going to give us x equal to 1, right? And y equal to 0. Remember that x represents the cosine and y represent the y, okay? Remember that x represents the cosine and y represent the sine. So apparently that when we take the size of 0 degree, which is basically the same as size of zero in terms of the radian, so that we equal to zero. So at this point, when theta equal to zero, that we can literally see, we cannot see any value for the y. So the y will be equal to zero, and x will be equal to 1. So for that point, that we can check that x equal to 0 and y equal to 1. Apparently, the cosine of 0 degree basically the same as the cosine of 0 radian, and which is equal to 1. And then we can also check with the with this part, and that literally going to give us the answer like that. So now we're gonna go to another part of the questions where we want to look at how the unit circle looks like. And let me just go back to the thing that we have right here and check how it's going to work. Okay, so let me just go to the course and let's go to this part, go to learning modules, and now we can check for the unit circle function that we can literally check. So this is the blank unit circle, and we actually have the few unit circle that we can literally see how nice this is. I can literally, I have to download it, but anyhow. So this is where we have the x and y, right? So x represent the cosine, and y represent the sine. So the cosine at the radian equal to 0, basically equal to for the cosine is 1 and sine equal to 0. When for the 90 degree, the cosine will be equal to 0, and then the sine equal to 1. Now, our job is going to analyze all of that. So let me just let me just copy out this part and put it on the Zoom. And so apparently that we can check for 180 degree. So how does it go? It's very important that we should be able to check this one. The angle go counterclockwise. Okay, so the theta go counterclockwise. Okay, so okay, let me just rewrite this part. So the theta basically started at x equal to 0, right? X equal to 1, 0, and then let's go all the way in this case. So the starting point should be this part. We can literally check. So this is a starting point. Let me just rewrite this. And this part that we can check that the data is going counterclockwise. Okay. So what happened if the data is going clockwise? Didn't mean that it's gonna get negative. So start it right here. So let's say go to that part, which is, so we call it, this is negative pi over 2, right? Because it's go counterclockwise in this case. However, that we can literally see that it's also the same as 3 pi over 2. So the most important thing that we need to know is that the sine cosine is periodic functions. So when it comes to the sine and cosine, it's just so every 360 degree or 2 pi is repeat itself. Or 2 pi. So you basically come back to the original point, right? Repeat. Okay. So this is what we usually write in terms of the angle. And for sine cosine, that we go into rewrite them. So this is in terms of the radian. So that would be at 2 pi. So every 2 pi, so we better to put k r. So whatever the term n, some people use n for that. 2k pi. So what that means is that um, the thing, every single 2 pi is come back to the original point. So we pick any points right there and then draw like another circle that goes counterclockwise. So up to that point, it just repeats itself. Okay, so every 2 pi. And then now we're going to analyze for the rest of the point for the special angle. And so for this part that we can literally check, so this is where we get the pi equal to negative, I'm sorry, the pi equal to 180 degree, which is a pi. And what is the point that we have? So we can literally see the side of 100 degree, 180 degree, which is size of pi, right? So psi represent the y equal to 0. So look at the y-axis. So this is the sine, and this is the cosine for the unit circle. Okay. So just want to make sure that we don't get confused. In this case, so size of pi, which is size of 180 degree, equal to 0. But the cosine of pi, on the other hand, that we can see that after 180 degree, it's go from the left to the right, and the answer will be -1. Okay, and similarly, well, we have to go there right there. And for this point, that we can check the size of 3 pi over 2 that we have is -1. And the cosine of 3 pi over 2, which is 270 degree. And the answer for that is 0. So apparently this is equal to 0. So remember that the x represent the cosine and then the y represent the sine. So when you read those things, you should be able to rewrite them in respect to the sine cosine. Similarly, we go to like the cosine of theta of 360 degree, which is 2 pi. So that basically means that we draw for the entire circle, and then this one is just come back to the point. Basically the same. So the cosine of 360 degree would be the same as the cosine of 0. So that would be 1. And the size of 360 degree, that would be the same as the size of 0. So that would be equal to 0 as well. So this is what we need to play a little more attention for that. So for that example, that we can rewrite the size of 2 pi, which is the same as the size of 0. And that would be, let me just draw this one. I just want to give some space right here so I can write a little better for that. Okay, so let me just rewrite this. So this one, cosine of 2 pi in this case will be equal to 0, and then the the cosine of 2 pi, and that would be equal to 1 as well. So that basically the same. This guy is same size of 0. So every 2 pi is just repeat itself. Okay, and then we can also rewrite this in terms of the cosine of 0. So in this case, that we have is a cosine of 0, also equal to 1 as well. Okay, so now we're going to end the lectures here and then come back and how you read the other stuff as well as the clockwise thing is basically proving the same thing. It just depends on how we're going to take the direction of that.